Let us see composite function and bijective function. Definition. Let X be a non-empty set. The identity function on set X is denoted by id suffix x. It is function from set X to X defined by id x of A is equal to A for every A in X. In short, every element is mapped to itself. The next definition of composite function. The composite function of function f from x to y and function g from y to z is denoted by g composed with f. It is function from x to z and it is defined by g composed with f of a is g of f of a for all a in x. First problem, we need to find composite function g composed with f and f composed with g, where function fx is defined as 3x square plus 2 and function gx is defined as 11x plus 2. Solution. Since f is function from R to R and g is function from R to R, the g composed with f function is from R to R. And to find g composed with f of x, we write g of f of x. So gx is 11x plus 2. So g of fx is 11 times fx plus 2. Further, we substitute for fx, that is 3x square plus 2. So 11 in the bracket 3x square plus 2 plus 2. And when we will simplify, we get the final answer as 33x square plus 22. The other way to do this simplification is g of f of x. So first I will substitute for fx. So g of 3x square plus 2. Then apply g. So I will get 11 times this bracket 3x square plus 2 plus 2. And after simplifying, I will get the same answer. Next, to find f composed with g. Now g is function from R to R, f is function from R to R. So f composed with R is function from R to R, and f composed with g of x, it is f of gx. So it is f of, I will use definition of function g, it is 11x plus 2. Now I will apply definition of function f, that is 3 times this bracket the square plus 2. After simplifying, finally we will get f composed with g of x as 363 x square plus 132 x plus 40. Now next definition of invertible function. A function f from x to y is said to be invertible if there is function g from y to x such that g composed with f is identity function on set x and f composed with g is identity function on set y. The function g is called the inverse of function f. We have important theorem. A function f from x to y is bijective if and only if function f is invertible. Problem is to show that this function h defined as hx is equal to 6x minus 9 is invertible, and we need to find its inverse. Solution. For function h from R to R defined as hx equal to 6x minus 9, the inverse function g is from R to R defined as, now see what happens for this function h, we are multiplying x by 6 and then subtracting 9. So in the inverse function, we will add 9 and then divide by 6. Let us verify that this g composed with h is identity and h composed with g is also identity. So let us start with g composed with h of x. It is g of 6x minus 9. So when I apply g function, I need to add 9 and divide by 6. So this minus 9 will get cancelled and I will get x. For H composed with G, first I apply function G, so I'll get H of x plus 9 divided by 6. That is, look at the definition of H, 6 times x, so it is 6 times this bracket minus 9. So 6 will get cancelled, and then 9 will get cancelled, and I will finally get x. Thus H composed with G is identity on R, and G composed with H is also identity function. Hence function G is inverse function of function H, and function H is invertible. Now I am giving you two exercises. In the first one, you need to find G composed with F and F composed with G. And in second one, you need to show that this function is invertible, find its inverse, and justify why it is bijective.